So basically what Intel do, we manufacture PVC ducting, subducts that can go into that PVC duct, and also blown fibre tubing. Just copy the first slide. So there we are there. We're based in Hawick in the Scottish borders. Just like I said just now, we manufacture PVC duct, polyethylene subduct, and also blown fibre tubing, which we started manufacturing in the early 90s under licence from BT. So the next few slides are looking at how things have actually developed. The normal way of doing things in the UK was you put in a 110mm PVC duct, you'd subdivide that by putting in subducts, and then you'd pull in a cable into those subducts. What's basically happened is, next slide. Here we go, in the 1980s, you had an 8-fibre cable, so a cable with 8 fibre in it, and that was about 10mm in diameter, and that would be pulled into a subduct or into a main duct. You can see there, as things have gone along, basically what has happened is the fibre counts have increased and the cable diameters have decreased. What that basically means now is that you can now have a 144 fibre cable that can go into a much smaller duct. Next one up. Click on the next one, just not much on there. So we go on the right hand side at the bottom there, there's two drums with subduct on there, different colours, that would be pulled into the duct that's sitting above it. So they're showing as that was installed, I've got a main duct, 4 subducts, each carrying 1 cable that will have a number of fibres in there. So it could be done now, with the cable diameters coming down, those can go to much smaller ducts, so I could subdivide that main duct now with lots and lots of smaller ducts to then blow the cable through there. It doesn't have to be pulled, you can actually blow that through. The advantage of doing that is the distance is greatly increased and you're installing the cable under no tension at all. It's effectively a cushion of air almost, carrying the cable all the way through the duct. There we go, that's just like I said. Probably just on the next one. So that's looking at a normal way of pulling a cable into a subduct. Just on the next one. That's some of the different tube bundles we manufacture. Basically, in a basic sense, we manufacture a lot of different tube bundles depending on what the customer actually requires. So external grade products, if you like, there's a direct install product that could be pulled or blown into a subduct or into a duct that's already in the ground. If you've not got a duct infrastructure in place, you could put in a direct buried tube bundle, which could be buried directly in the ground, as long as the ground's prepared correctly. It's not just a case of dig open a trench, throw it in and bury it again. Because what has to happen afterwards, you have to blow a cable or a fibre into there. So that process has to be able to be carried out. We do low fire hazard products for inside buildings, and there's other special products, termite resistant layers for if you're in the area where there's a problem with termites, rodent resistant layers if those are required. We also do aerial tube bundles as well, so if you have a pole infrastructure in place, you could run the tube bundle aerially as well. On those, there's a range of different, you see the primary tube sizes. What that means is actually the individual small ducts inside this cable. So that's effectively what it is. It's a cable with, it's basically an empty fibre optic cable. So there's a range of different microduct sizes you can have in there, again depending on how much fibre you need to get from one point to the next point. And there's a different number of those microducts you can have in the, what we call the assembly, or in the cable. So the largest one you do is 24 tubes, which is basically the one that's shown there. Again, can have a look at this later on, a bit easier. Again, that's just sort of building on from what I said earlier. There's different ways that the network could actually be built. Different ways products can be deployed, obviously depending on the choice of product that's been made at an earlier stage. Or this could lead to actually which product you're actually going to use. So starting from the top left, as you're looking at it, that's a slot cut in the road. So someone comes along with basically a road saw, cuts a slot in the road, drop the product in, reinstated. The one in the middle is a traditional open trench. Next one at the far right hand side is a mole plough, which is one of the methods that was actually used on Cybermoor. Under that we have an aerial network. Next one over again is a slot cut. Next one is actually in a sewer deployment. So again, if you have a sewer network or culverts or some other way, you don't actually need to dig. If you can get access to those and get permission to use those, you don't need to do any digging at all. The only difficult thing might be the sort of maintenance point of view, as well as finding someone that's willing to go into the sewer network to put it in. And then the last one is a traditional sort of UK build where you've got a duct network and then the cables put into that duct network and you've got access chambers at certain points along the route. So that's looking at an open trench technique. So the one downside of that is that you have long lengths of trench open for a period of time. So that obviously needs to be looked at, but your installation company will obviously be looking at that as well. There may be certain regional differences that the local council may say they can only have a certain amount of sort of open trench open at any one time, obviously for safety reasons. Next one. Again, that's just building on what I said earlier on. Starting from the top left, you've got PVC duct subducts. The way they do it in Europe, polyethylene duct with a direct install tube bundle in there. One of the products we make is actually a subduct with tubes already installed, and the last one is a direct bury assembly. Obviously, depending on what you have in the ground already, will determine what you actually use. Let's skip on the next one. That one there just shows some of the machines that can be used. Those are actually for putting a larger cable into a subduct. Take a while to load the next page.
Just explain how the blowing works.
Yeah, basically the blowing works regardless of what size the cable is or what size the duct is. You're basically putting you've got a compressor that will run at 10 or 15 bar air pressure. That air then goes into a blowing machine. From that blowing machine, the air travels down the duct or tube and has to be allowed to come out the end. That creates a pressure gradient. It's actually that pressure gradient, so the difference in pressure from the start point to the end point is actually what carries the cable through. That side there is just looking at different types of mole plough. This is there, trenching, direct and deep. The advantage of doing mole ploughing is that basically you see it there, regardless of the size of the machine, it basically goes along, cuts a small channel in the grass verge. It'll actually lay the product in at the same time, and then because it's such a small channel, the channel actually closes over afterwards. And then maybe after 2 weeks, you could go along that grass verge and not actually see that there's been anything actually in there. We can also manufacture pre-cabled subducts, so a subduct with a cable already installed. So when that needs to be installed in the ground, in case you lay it out, you've already got the cable in there. The advantage of doing that is at a later date, if you need to remove that cable, you can. You don't then need to dig up again. You can remove the cable and put in a new one. Slot cutting is being used more and more. Again, it depends on the area and depends on the conditions where you have to install the product. The ones that are shown here are actually from a project where we supplied the products on, I think it was in Malta. So they were allowing us to, well, allowing the product to be installed along basically a motorway. So it's on the hard shoulder, The advantage of this is it's a really quick method of doing it, and that was basically what they're using for their backbone. So they use the motorway as a backbone, because that's, if you imagine the sort of the fibre optic network as a roads network, that's basically what it is as well. Your backbone's your motorways, and then you're coming off from there onto your A roads and your B roads. That's looking more at sort of in-city or in-town environment for doing that. The one downside as well is the mess that can be left as well. Because you've got a cutting disc, you need to cool down that cutting disc, and you sometimes get this sort of slurry left over. But there are different machines that will actually take that away at the same time as well, so you're not left with that. Like I said earlier, if there's tunnels that you can use or culverts that may actually save you time and money, it may be beneficial to actually put something in there, put your cable in there to get you from where you want to go. That's basically the fibre unit blowing machine. So that goes into the smaller range of tubes. It's similar to this one here. What's actually shown there, again you can get a closer look later on, is this is a sort of this could be running down your street, and at each point I need to drop off to a house. I'll just do it in a simple box like this. The installer that puts this in basically does a simple plumbing job. That's all they do. They take a tube from here to a tube from here, put on a connector, and that's it. I've now got a network all the way from my exchange or my point of presence directly to the customer, using a single tube coming out going to them.
So that's a duct tube, not a fibre.
Yes, that's right. Because then what you do is you build this network, and then you come on with a blowing machine and you just blow the fibre point to point. Well, point to multi-point if you like. So one of the things people always ask is how far can you actually blow the fibre? It depends on a number of things. Obviously the sort of what was I going to say just now? It depends on a number of things. Basically, the size of the microduct, the size of the cable you're trying to put in there. Because obviously a bigger cable's got to be larger, well, it's bigger for starts, and it's got to be heavier as well. As a rough idea, 1,000 metres is sort of an average distance you could get. If things are working in your favour, you'd be looking at longer than that. It's really just trying to match up the microduct size to the cable size, and that's really the thing you're looking for. If you want to go longer, you go for a bigger microduct and a smaller cable. Go to the next one. Like I said earlier, when we're looking at different types of products, there's also, as well as the standard range of products we do develop bespoke products as well for a particular customer's needs. As long as we can basically find a plastic that we can manufacture a tube bundle that will meet the requirements of the actual customer. So what we're sort of looking at is the cost of the network build is low. Over a period of time, it is low. To start off with, again, it was mentioned earlier as well, a tube bundle approach may be more expensive for your particular network, but you need to change anything on that network and it really comes into its own. Say for instance, you give someone 2 fibre, but in 2 years time they want 4, you can blow out the 2, blow in a 4. You've no disruption to the network at all. You're not having to dig up any streets, you're not having to do any more sort of civils work. It's a simple job of just blowing out a fibre, blowing in a new one. So that's the sort of the upgradability and the future proofing as well. In 10 years' time, a new fantastic fibre comes along that is far superior to anything that there is just now. Again, you can blow out the fibre, blow in this new one as well. It's just as simple as that.
Okay, we're almost at time.
Yep.
So do you want to take some questions?
Yeah, take some questions, yeah.
So we've got any questions for Dave?
Yeah.
Could you go back to the slide with on the aerial poles? How do the tubes compare to? I'm just trying to think how they compare to the size of standard wiring on telephone poles, and What would drive that solution rather than putting it in the ground?
I think what would drive that solution is if there wasn't a duct network in place already, or say you're in quite a congested area, where it might make more sense actually, if there's a pole network in place, to do that and distribute to a number of homes aerially rather than doing it under the ground. I think it's like you said earlier, there's probably not one, no, there isn't one solution to work everywhere. And what you might find is that even for this part, it may be an underground network to one pole. You come up that pole and then feed 6 homes from there, but it's underground for the rest of the way. You might not necessarily do a whole network as an aerial network. You may use a combination of different ways of doing it.
But if your town like mine has got lots of telegraph poles
Yeah.
still,
Yeah.
and the width of those cables doesn't seem to be that different to...
It's not actually, no. Again, it's like you say, if there's an underground network there, you could take a number of tubes to that point, the rest of them could carry on, but you only take up, and you're only putting aerially the number of tubes you need to get to that point, if you know what I mean. Rather than taking, say, something like that one there, which has got 24 tubes in, you may not take all that aerially. You may come to the bottom of a pole, split it, take 7 up, and run 7 aerially to feed 7 homes.
Sorry, I've got a question about the range. So if, for example, you've blown it through, say, a sewer network, but then you need to blow it another 1,000 metres up a hill, is that possible?
Yeah.
It is, yes.
Basically, the fibre comes in a... Gosh, it comes in almost like, if you imagine like a big sort of pizza box. It's like a donut-shaped pizza box, if you like. All the fibre comes in that, so you could get 4 kilometres of fibre in something that's this high and this diameter. So what you can do is, because it's in that box, you've got one end here, the other end is at the bottom, taped to the bottom of the pan. So I can blow as much as I want in that direction, and then flip that over to blow this free end out in that direction. Or I could have an empty box at the end, so I can blow 1 kilometre with an empty box, carry on blowing into that empty box, flip that over, move the machine up, and just carry on doing that. Because actually because basically the length that's put in here, if you're saying it's 8 kilometres long, there's 2 4-kilometre drums of cable that were installed just by using a range of different techniques to get that in one continuous length. There's no intermediate splicing required.
What do you think is a safe amount of redundancy for numbers of fibres?
I really don't know. I don't know. Normally, what we used to always say was, say if you go into a business, you might put in 1 extra tube to that business. But then you've got the option, because the fibre unit comes in different quantities, you could have 2 fibre up to 12 fibre. So you have the advantage of putting in up to a 12 fibre into that customer. So there's the flexibility on that side as well. And when it comes to cables, like say, you can go up to 1 4-4 fibre cable.
Okay, that's great. Sorry, we're almost out of time, so would you mind asking that question in the fibre workshop after lunch?
Right.
Is that okay?
Brilliant. We're going to the fibre workshop, that's why.
Oh, right, okay, is it quick?
Very quick, I just wonder if you could comment on comparative wheelie costs.
I couldn't know. No.
We pay.
You might, I'll talk to you later.
Okay, that's great. Thanks very much, Dave.
Thank you.